Disappointment comes from expectations being broken. Think about the first time you saw that YouTube played 2 ads instead of 1. You expected 1 and you were met with suffering. But although we can understand that expectation is the thief of joy and disappointment comes from the breaking of that expectation, here I want to ask, where does disappointment really come from? Turns out there is a culprit. So let's see what part of the brain I can make you want to lobotomize by the end of this video. Before we introduce the antagonist of our story, we need to build the world and the characters first, because I want to see season 3 of Cells at Work. The brain uses chemical and electrical signals to communicate, for emotions, for moving your muscles, quite literally everything in your body. Here, we'll be focusing on those chemicals, which can be grouped into 2 groups, neurotransmitters and hormones. The main difference being that hormones are secreted by the endocrine gland into the bloodstream, and the neurotransmitters are from the nervous system and they travel across synaptic clefts. There are some chemicals that can be both a hormone and a neurotransmitter. Epinephrine or adrenaline, for example, the best known fight or flight chemical, that one can function as both. In this video, we're going to be focusing on neurotransmitters specifically though. Neurotransmitters can be grouped in many different ways. Their chemical or molecular properties, what part of the brain they usually hit, what they do. Here we'll be focusing on the grouping of inhibitory and excitatory. Inhibitory neurotransmitters are neurotransmitters that slow things down. Inhibitory neurotransmitters prevent chemical signals from being sent. They make neurons less likely to fire. You can think about inhibitory neurotransmitters as being important for something like, say, sleep, where you want the body to slow down, where you want the mind to stop ruminating about all the mistakes that you've made in your past and how all of them are going to lead to your failure in the future. 2 examples of inhibitory neurotransmitters are everyone's favorite feel-good neurotransmitter serotonin, and even more popular in the inhibitory space, and the one that we'll be looking at here, is gamma-aminobutyric acid, better known as GABA, which accounts for about 40% of all of the inhibitory responses in the brain. Excitatory neurotransmitters are the exact opposite, of course. They speed things up in the body. They make neurons more likely to fire. Excitatory neurotransmitters are the reason that you pee your pants when you're scared. Oh, and just like last time, there are some neurotransmitters that can be excitatory or inhibitory depending on the receptor they hit. Fun fact, we know of about 60 neurotransmitters in the brain. With so few neurotransmitters in your brain needing to do so many things, the receptor is just as important as the neurotransmitter in determining the reaction. But 2 examples of excitatory neurotransmitters are the most misunderstood neurotransmitter, dopamine, which is way more of a learning neurotransmitter than it is a simply pleasure neurotransmitter, and even more popular in the excitatory space, and the one that we'll be looking at in this video, is glutamate, which is the main excitatory neuron or neurotransmitter in the brain. It's not a neuron. GABA and glutamate are kind of the slow, fast duo in the brain when it comes to excitatory and inhibitory. Now that we've covered all of the material on exam 1, let's go over our characters and introduce our antagonist. We have GABA, which slows things down in the brain. It says no. And then we have glutamate, which speeds things up in the brain. It says go. And then as for our antagonist, the source of your disappointment, at least in the brain, and this is just to what we know right now, if you're watching this video 10 years in the future, I'm sure it's much more complicated, is the habenula. Aside from having a cool name, this still being understood tiny structure seems to be the source of disappointment in the brain. Although there is some stuff about it being involved in sleep and some other things, no part of the brain just does one thing. But the habenula connects the limbic forebrain and the midbrain. The limbic system is the emotional center of the brain, and the midbrain is involved in motor function as well as sensory processing, specifically sight and sound. The habenula takes input from the limbic system and it outputs into the midbrain. The habenula is an older part of the brain, just as the limbic system is. If you're not aware of current human neurological evolution theory, I really thought that would sound better. It's thought that the emotional part of our brain, sometimes called the lizard brain, or as the cultured people would call it, the monkey brain, is thought to have been present in early humans much before our thinking brain like sometimes called the neocortex, meaning new cortex, or the big brain in contrast to the monkey brain. The midbrain and the limbic system are considered to be a lot older, and the habenula connects them, so it's also considered to be reasonably old in terms of when it came about in human evolution. Through research, we found that the habenula is more active when we're disappointed. Specifically, we found that monkeys get more active habenulas when they don't get an expected reward. Monkey get no juice, monkey get disappoint. They probably couldn't get IRB clearing to do this with humans because who could live without their juice? Again, the habenula is involved in much more research involving depression, some stuff about sleep. We're looking at the niche topic of disappointment in an even more niche area of the brain. So the research is a bit sparse in this field. Bringing our duo back into the mix, glutamate and GABA regulate or control the output of the habenula. Although we said that the habenula is the antagonist of the story, it turns out that the real antagonist is actually glutamate. Plot twist, right? Glutamate excites or turns on the habenula, which will then inhibit the firing of monoaminergic systems within the midbrain. And monoaminergic is another way to classify neurotransmitters. Specifically here, we're talking about the feel-good neurotransmitters, serotonin and dopamine, which are monoamines. The GABA then turns the habenula not on. It seems it's not anatomically correct to say that GABA turns the habenula off. That doesn't really make sense or work, but you get the point. It inhibits the habenula from firing. So although we have this habenula, which I said was the antagonist, it seems that the habenula is actually the weapon used to make you disappointed, and glutamate is the guy that's trying to use the weapon, and GABA is trying to stop glutamate from making you disappointed. To better explain, the habenula gets fed with both glutamate and GABA. Now, if the ratio of glutamate to GABA is in favor of glutamate, the habenula turns on, therefore inhibiting the release of dopamine and serotonin in the midbrain. If the ratio, however, is in favor of GABA, the habenula will not touch the dopamine and serotonin being fired in the midbrain. As we explained earlier, the midbrain is involved in motor function and sensory processing. So when we get disappointed and we inhibit the midbrain, this may be why you feel a lack of motivation or a sense of heaviness in your body, not wanting to do things or not wanting to move much. When we inhibit the area of your brain involved in motor function, you will probably want to do motor stuff a little bit less. And this may also carry over into the feeling of disappointment. We know that hyperactivity of the habenula, so a lot of glutamate very often, is involved or does play a role in depression. So although disappointment may not make you clinically depressed, when you get disappointed, you may have a sort of shot of that down feeling, which we call disappointment. These two things, by the way, I didn't read them in a paper somewhere. This is just my understanding of why the feeling of disappointment may feel the way that it feels, with conjunction with the research that I have presented in the rest of the video. So full disclaimer on that one. This is me spitballing. I should say that. If you've got all the way through this video, you're either a fan of neurology, you like learning things that don't impact your life, or you're my friend. If it's the latter, thank you so much for your watch time. If it's either of the former, thank you so much for hitting the buttons. Overall, disappointment isn't as crippling as depression, anxiety, or chronic stress, but disappointment sucks. And after learning about disappointment, I've realized that I don't want such a minuscule and outdated part of my brain to control how I feel. I want to have more power over that. However, the real key to not being disappointed is, of course, not having expectations, which I talk about at much more length on my podcast episode on disappointment, which you can watch here on YouTube or anywhere that you get your podcasts. I will also leave it in the description. Thank you so much for watching this one. I will be in school by the time you watch this. So the uploads are probably going to slow down and you won't see me every Wednesday anymore. And if you do see me, it'll probably be something about electrical engineering. I'll do my best to get some Notion videos out as well as plot something out like this when I can, but research and writing takes a long time. But thank you so much for watching. I will miss you. Much love. Expectation is the thief of joy. Peace.